Alright, today we're going to look at topic 7 of chapter 6, which is solving radical equations. So, isolate the radical on one side of the equation, raise both sides of the equation by the n power, whatever the index is, and then solve. Check for extraneous solutions that do not make the original equation true. Okay, so make sure that your solutions actually work. Alright, so first we isolate the radical, which means subtracting 4. So if we subtract 4, that would leave us with the square root of x plus 2 equals 3. At this point, we get rid of the radical. The index is 2, so we raise both sides to the second power to get rid of the radical. That would leave us with x plus 2 is equal to 9. At this point, we subtract 2, and we get x is equal to 7. Okay, 7 is the solution, and we're going to check to make sure that this works. So we do 7 plus 2, which is 9. The square root of 9 is 3, and 3 plus 4 equals 7. So this definitely works for problem number 1, and that is the appropriate solution. Alright, number 2, we isolate the radical part, so we get rid of the plus 1. We got 6 is equal to the cubed root of x minus 2. Alright, at this point we get rid of the radical by raising to the power of 3 to get rid of the index, or to get rid of the root. So 6 to the third power is 216, and this is x minus 2. Finally, we add 2, and we get 218 is equal to x. So this should be the appropriate solution. Let's check it to make sure that it works. So 218 minus 2 is 216. The cubed root of 216 is 6. 6 minus 1 is 5. So this definitely works for number 2. Alright, number 3. We got negative 3 times the fourth root of x minus 1 equals negative 12. Well, first of all, we got to get rid of that negative 3. We got to isolate the radical. So we got the fourth root of x minus 1 equals 4. Alright, now we raise both powers to the fourth, or both sides to the fourth power to get rid of the index, and we're left with x minus 1 equals, let's see, 4 to the fourth power. We're going to have to use a calculator here for this one. 256. Okay, add 1. So x equals 257. Alright, let's check to make sure that this actually works. So let's put it into the equation. So 257 minus 1 is 256. The fourth root of 256 is 4, and negative 3 times 4 is negative 12. So this definitely works in problem number 3. Alright, well, what about when we have radical equations on both sides, like we do here? Alright, so what do we do when we have radicals on, where'd we go? Yeah, radicals on both sides of the problem. So for example, number 4, square root of x minus 12, and 2 minus the square root of x. Well, we're just going to have to get rid of both radicals at the same time. Okay, so what I'm going to do is I'm going to square this side, and I'm going to square this side. Okay, so if I square this side, then the index cancels, and I'm left with x minus 12. Now, if I square the right side, I can't really just cancel out the index, so I have to write it expanded. 2 minus square root x times 2 minus square root x. And then at this point, I can use the distributive property to simplify this. So 2 times 2 is 4, minus 2 square root x, minus 2 square root x, and then negative square root x times negative square root x would be positive square root x squared, which is just x. So I got x minus 12 equals 4 minus, and okay, so let me combine the like terms here and put it in the proper form. So that would be negative 4 square root x. So this would be x minus 4 square root x plus 4. And over here we have x minus 12. Okay, now the goal, since we're down to only one radical, we've only got one radical term. At the beginning we had two radical terms, now we only have one, is to get that one radical term by itself. Okay, so the way I'm going to do that is I'm going to move everything else to the left side besides that term. So I'm going to move the x to that side, which is going to cancel with this x, and I'm going to move the 4 to that side, which is going to make this negative 16. So what I end up with is negative 16 equals negative 4 root 6. Divide both sides by negative 4, and we get 4 is equal to the square root of x. And then we can square both sides here, and we see that x is equal to 16. Alright, let's check to make sure that this solution works in the original problem. What's going on with my eraser here? Okay, let's make sure that it works in the original problem. Alright, so I got 16 minus 12, which is 4. So I got square root of 4, which is 2. So the left side's 2. On the right side, I have 2 minus the square root of 16, which is 2 minus 4, which is negative 2. Okay, so solution 16 does not actually work because if you use 16, the left side is 2 and the right side is negative 2. So 16 is not a solution. So this one does not have any solutions. Okay, because the only possible solution is 16, and 16 doesn't work. Alright, so that's not going to work. Alright, let's move to number 5. Now number 5 is easier because both sides have radicals, but luckily they both go away just by square rooting. We end up with x minus 4 equals 2x minus 13. Squaring this side and squaring this side, they cancel. Alright, now I can just solve this as a regular equation. I will move the x over, and that gives me negative 4 is equal to x minus 13. I'll move the 13 over, and that leaves me with x is equal to 9. And let me check this in the original equation. It should work. 9 minus 4 is 5, so the square root of 5. And then 2 times 9 is 18. 18 minus 3 is 5, so this side is also the square root of 5. So both of these are the same. They're the same number, so this is definitely the solution. Alright, number 6, we need to get the radical by itself. So we add 4 to both sides, and we're looking at the cubed root of 4n minus 8 is equal to 4. We get rid of the radical by cubing both sides, because that'll get rid of the index. So you got 4n minus 8 equals, I want to say 64, but I'm going to put it in the calculator just to make sure. Yeah, 64. And then I can just continue to solve this. Add 8. So 4n equals 72. Divide by 4. And that gives us 18. N is equal to 18. Okay, let's check this to make sure that it actually works in the original problem. Okay, so we have 4 times 18, which is 72. 72 minus 8, which is 64. The cubed root of 64 is 4. 4 minus 4 is 0. So yes, 0 on the left side, 0 on the right side. Good. Number 7, 3y minus 2 to the 1/5 power plus 5 equals 7. Well, remember, this really just says the 5th root of 3y minus 2, and then plus 5 equals 7. Okay, so we subtract 5 to get the radical by itself, 3y minus 2 equals 2. Now I get rid of the index by squaring, because, oh sorry, not squaring, this is not a square root, it's a fifth root, so we get rid of the index by raising to the fifth power. Alright, so the left side becomes 3y minus 2, and the right side becomes whatever 2 to the fifth is, which is 32. Continue solving, so plus 2, 3y equals 34. Divide by 3, and this is not simplifiable, I don't think. 34 divided by 3, yeah. This doesn't simplify, so it's simply 34 thirds for y. Let's go back into the original problem and plug that in and make sure that it works. Okay, so we got the fifth root of, so this is the original problem, 3 times 34 over 3 minus 2 plus 5 equals 7. Okay, so I'm checking it right here. I'm checking the problem right here by plugging it in for y and making sure that it works. So the fifth root of 34 minus 2, because those 3's would cancel, plus 5 equals 7. So that's the fifth root of 32 plus 5 equals 7. Fifth root of 32 is 2, because it's 2 times 2 times 2 times 2 times 2. So 2 plus 5 equals 7, 7 equals 7. Okay, so this solution works for number 7. Good. Alright, so number 8. Square root of x minus 6. I'm going to need another page to do this. Square root of x minus 6 plus the square root of x equals 3. And we want the solution to this. Alright, now it's going to be kind of hard to do it like this with both these radicals on the same side. They can't be combined because they don't have the same radicand. And if we multiply them, if we square this side and this side, it's not really going to help us out that much, I don't think. So let's just move this square root to the other side, and that might make it a little bit easier. So you got the square root of x minus 6 equals 3 minus the square root of x. It's possible that we didn't have to do that, but I think it's going to make the problem easier if we do that. So now we're going to square both sides. The reason it makes it easier is because now this side is just x minus 6. This side is 3 minus square root x times 3 minus square root x. We use the distributive property here. So we got x minus 6 is equal to 9 minus 3 root x minus 3 root x, and then plus x. We combine the like terms and we have x minus 6 equals x minus 6 root x, because there's 2 of them, and plus 9. Alright, now the goal is going to be to get this square root by itself. So I can move this x over here and it will cancel. And I can move this 9 over here and that'll give me negative 15. Negative 6 and negative 9, negative 15. I move that. So negative 15 is equal to negative 6 square root x. Alright, divide by -6, because we're trying to get the square root x by itself. So that will give me 15 over 6, which simplifies to 5 halves, I think. Because 3 times 5 is 15, and 3 times 6 is, or 3 times 2 is 6. So I end up with 5 halves equals the square root of x. Alright, now I can square both sides to get rid of the radical. So this would be 25 over 4 is equal to x. Okay, so I do need to check this to make sure that this actually makes sense. This is a little bit harder to check in this problem, but we are going to have to do it anyways. So I'm going to take the original equation, and my solution is 25 over 4. I'll plug this in and see if it works. So I get the square root 25 over 4 minus 6 plus the square root of 25 over 4 equals 3. Okay, well I know that 25 over 4 is square root. That's 5 over 2. I just need to figure out what this is. So I can do that by finding like terms. Common denominator. So this is 6 over 1. So I'd have to multiply this by 4. So this is 25 over 4 minus 24 over 4, which is 1 over 4. And the square root of 1 over 4 is 1 over 2. So this becomes 1 over 2 plus 5 over 2 equals 3. So that's 6 over 2 equals 3, which 3 equals 3. So this is indeed the solution, 25 over 4. Because when I plug it into the equation, it works. 25 over 4 gives me correct answers on both sides. So that is definitely the solution to number 8. Alright, and that is how we solve radical equations.